Well, good afternoon, everybody. Before I go there, I think I should introduce the keynote speaker as well as the panelists today. We have Mr. Nameer Rahman. He is a Bangladeshi Canadian energy policy specialist. He is the founder and CEO of Prometheus Consulting. Mr. Rahman is a veteran policy and regulatory affairs specialist who most recently served as a senior advisor with Strategic Policy Unit of the Ministry of Energy in Canada. And in the panel list, we have very distinguished panels. We have Architect Yafis Usman. He is Honorable Minister for Science and Technology, Government of the People's Republic of Bangladesh. He is a valiant freedom fighter and son of a prominent writer, Shaukat Usman, a graduate of Architecture Department from BUET. He was the Vice President of the Engineering University Central Students Union in 1970. He is also a former Science and Technology Secretary of Bangladesh Awami League. And second panelist, we have Mr. Zunaid Ahmed Palak, Member of the Parliament, Honorable State Minister for ICT, People's Republic of Bangladesh. He is the youngest member in the history of Bangladesh Parliament. He is currently serving as his second consecutive term as a member of the Parliament. He is also the co-chair of the All-Party Parliamentary Group of Bangladesh Parliament on climate change. Next, we have Mr. Sanjay Kumar. He is the Executive Director of Climate Parliament. Sanjay Kumar combines long experience as a policymaker with a deep knowledge of both climate and energy issues, especially forest conservation. He is currently pursuing Climate Parliament's vision for a global grid powered 100% by renewables. Then we have Mr. Zamil Azhar. He is the Chief Strategy Advisor, Startup Bangladesh Project. And last but not the least, Mr. Mahbub Zaman. He is Managing Director, Datasoft Systems Bangladesh Limited. So I'm going to go there, and probably I'm the most powerful person today that I can call two honorable ministers as well as stop them if I want. So now I request a distinguished speaker as well as the panelists to come up on the stage. And I also request the audience, don't get sleepy. We will have an exciting discussion today. Thank you very much. Now I request today's speaker, Mr. Nameer Rahman, to present today's exciting subject. I was, just before I, since I'm the moderator, I have the chance to talk a little bit more. It is really exciting because I got the visiting card of Mr. Mahbub, where I see the logo, Changing Lifestyle. So probably this is a very appropriate, term that we are going to talk about. Today, we will talk about the changing the lifestyle in Bangladesh. Thank you. I invite you to go on.
Ladies and gentlemen, thank you very much for having me here. I'd like to thank the government of Bangladesh for inviting me, and specifically Architect Yafis Usman, the Honorable Minister for Science and Technology, Zunaid Ahmed Palak, the Honorable Minister for the State Minister for ICT, and our moderator, Dr. Ahmed Kaikus, Chairman, Bangladesh Energy Power Research Council, and of course our other panelists. Smart grid technology is what you'd call the cutting edge technology of the electricity sector. It is really a transformative set of technologies that's coming about all across the world. One of the things that you have to realize, or let me give you a perspective of where I'm coming from and how I got into this, I actually entered the energy sector through the oil and gas sector before transferring over to transmission and distribution policy. And in Ontario, I worked as a senior regulatory compliance officer implementing the first generation smart grid rollout back in 2008, 2009. That included smart meter technology, renewable integration, all through an act called the Green Energy Act. We got to see firsthand how smart technology worked, what its strengths were, and what its weaknesses were, because no technology is perfect. After that, I transitioned over to the Government of Ontario, Ministry of Energy, where I served as a senior advisor with the Strategic Policy Unit. And amongst the things that we did over there was look at systems in a larger perspective. So how do we do our long-term strategic asset planning? How do we do regional procurement planning, internal capacity building, and our long-term energy plans? So these are some of the projects that I've worked on. My approach to smart grid is not a theoretical one. It is based on my experiences in the field, in the sector, and with government. And the lessons that I try and bring forward are distilled through experience. To just get a roll on, smart grid is really a subsector of the Internet of Things. And the Internet of Things is really the digitization and the wireless communication or connectivity for everyday objects. However, when you start bringing in wireless communication and interactivity, you tend to have radical implications and effects in terms of how people live. The thing is, Internet of Things popped up in the last 5 years as a term, but the electricity industry saw this coming up back a decade ago, back in 2007, 2008, and they pioneered this concept called home area networks, which was pervasively connected digital homes that were always on. But this had a radical implication for power consumption, because if you have a lot of electronics on, it means you're drawing more power, and it could affect system stability. So they started thinking of how do we get to control this, and they started looking at behind-the-meter solutions for control and management of power consumption. And the concept of smart homes and smart grid goes back at least 10 to 15 years. Now, smart grid, according to the US Department of Energy, generally refers to a class of technology that people are using to bring utility electricity delivery systems into the 21st century. And the focus tends to be on wireless connectivity or communication structures that allow different elements of your electricity system to communicate with each other. The most common example is your meter, and a smart meter will communicate back into your command and control structure, and it'll communicate forward into your home. And a simple dead meter for utilities was the beginning of what you'd call a revolution. And smart grid, from a value of business standpoint, represents immense potential, and the last figure I saw showed that it had the potential of being at least $400 billion in terms of business value moving forward into 2020, which a few years ago it was only in the hundreds of millions. The thing about wireless communication and the thing about connectivity isn't so much that you're communicating, but it transforms what you do very fundamentally. And this fundamental transformation happened within the electricity sector, at least in Ontario and in chunks of Europe. What it did was it transformed the grid, which was single direction, generator, transformer, distribution line back to your home, into a multi-directional grid, where homes could now generate electricity and pump back into the grid. So you didn't just have a home that was a consumer. The term that they use over here is prosumer, a producer and a consumer at the same time. The electricity sector in North America is an asset-based business model where you earn a rate of return on the value of your assets, Well, smart grid technology allows you to make money on the services that you provide, and there are some really interesting and unique services that come about. It has facilitated the rise of new technologies such as electric vehicles, renewables, storage, advanced meter infrastructure. And here's the critical bit. It is data-driven, because data is what's going to change the world. Information is what's going to change the world. And data with analytics, it's really what's going to unlock smart grid and the Internet of Things in the future. And it takes a dead grid where you physically had to go and switch controls and levers to reorient lines with real-time control and pervasive awareness. You know what's going on all the time. What most people don't talk about when it comes to smart grid technology is the behavioral change and impact. How do you get people to change the way they're consuming power in a way that makes sense and in a way that's beneficial not only for the grid, but for the nation and the individual? Smart grid in Ontario, right now, as it stands, has a few core elements to it. You've got a regulatory policy that's enabled or enacted through the Electricity Act. You've got three-tier pricing, so time-of-use pricing for average homes. You've got meter data management, a centralized repository where data is sent. You've got a smart grid working group that pushes forward in terms of what that next generation of smart grid is going to be. Research and development money to tackle critical issues. It's about anywhere from $50 to $100 million. The Green Button Initiative to access your own data so that you can see how you're consuming power, and market-ready smart grid services that can complement whatever infrastructure you put up there. So these companies can come in and say, we can help your system more efficiently, run more efficiently. The potential benefits are massive. Reliability, so you're increasing grid resilience and reducing outages. Efficiency, high levels of automation, so you can do things faster. Cost, you avoid costs, you defer costs, and you increase the value of your investment that you put in. Safety, fault detection, and anti-islanding measures. So if you put in a solar panel and your main grid goes down, you make sure your line workers aren't electrocuted because they're touching a live wire. Control, so you can go ahead and proactively reorient your system or your electricity grid as needed moving forward. And financially, and the final component is the financial. It actually provides for new business models to be created and implemented that allow for new opportunities to be engaged in. And I'll get into that a little later on. I firmly believe that you shouldn't implement technology for the sake of implementation just because it's technology. That you should try and address problems on the ground. You deal with the problem, you work with the problem, but you apply the best solution possible for that particular issue over here. So my presentation is oriented towards 6 key issues that I think would be relevant in the context of Bangladesh's grid. And then I'll talk a little bit about which technology sets best apply to it. The thing about technology is it's constantly evolving. If I can talk about something right now, chances are 6 months down the line, somebody's created something better. So to fixate on a technology type or a technology class might be the wrong approach. Look at the problem, look at the solutions look how you can try and solve that problem and apply your right sets of tools and technologies to it. So I'll be talking about transmission and distribution losses, rural electrification, system reliability, peak shifting, large renewable integration, and environmental and greenhouse gas impacts. And that's the rough order or the hierarchy of importance that I put it in. You may disagree, but we can have a conversation about that moving forward. Now, everybody knows what loss factors are, but for those who might not know, that there are really 2 types of losses on your grid, and that's called technical losses, which are thermal and resistive. So as energy is pushed down a line, you lose some of it, especially on hot days. And transformative, as you're stepping up and stepping down power, you lose some energy. And then you've got non-technical losses, which are theft and theft of power, parasitic load, station load, so the energy that you use to run your station before you pump it out. Now, the average system loss in Ontario, in the US, in the UK is somewhere between 6 and 8%, generally about 7%. This slide is a little out of date. I was informed by the Prime Minister herself yesterday in her wonderful opening remarks that Bangladesh's loss factors are actually down to about 10%, which I didn't know. The best figures I could find from the World Bank were about 13 to 15%. But the fact of the matter is, loss factors, especially excessive loss factors, have two huge impacts for a country. First of all, it reduces your financial situation because you're not getting money for the power that you're generating. And number two, you don't know what's wrong with your system. You know, when you've got high technical losses, transformative or thermal, there could be issues at your transformer station. You could be having overly long feeders, etc. This requires asset management strategies. Loss factor revenues, basically, if you have 60,000 gigawatt hours of production a year, and you've got a 13% loss factor and you want to bring it down to about 5%, that 5%, if it were just theft, represents 200 crores in takas from loss revenue for the government and for the system stability. The equivalent loss generation is about 650 megawatts of gas generation, 462 megawatts of hydroelectricity, and 400 megawatts of nuclear or biogas. So the question I'd pose to you is, would you much rather just get rid of your loss factor, or would you much rather contract new generation? And it doesn't make sense to contract new generation when all you have to do is find those losses and start bringing it back. It is cheaper. The reality is that with transformer and distribution losses, that it'll be a mixture of revenue and reduced technical losses. But what key technologies can do is, in terms of where your transformer stations are being handled, how you do your power voltage controls, how you take a look at your advanced metering infrastructure can help bring this down. And particular importance is your metering infrastructure. Smart meters will tell you down to the watt how much, or even less than that, how much electricity you're consuming. You can track line by line, house by house, item by item, where the power is being generated, where it goes to, and isolate what's going wrong over there. And what that means is, if it's a technical thing, it helps you save money in terms of your asset planning, so you can just focus on what's wrong. Or if it's losses, you can go after people and say, you're stealing energy. You either put in a meter, pay up, or disconnect them. But the fact of the matter is, transmission and distribution losses represent one of the biggest opportunities, not only in terms of financial stability, but from a grid modernization standpoint for developing countries. And smart grid technologies like AMI, like smart metering, like your transformer side, like your power voltage controls, allow for these opportunities to be realized. Let me tell you, in Ontario, or in some of the literature that I've seen, they're now talking about using smart grid technology to put loss factors down to about 4%, which for me is absolutely amazing. So when you're talking about even 10%, bringing it down to about 7% or 6%, smart grid technologies can help you realize those efficiencies without having to invest in additional generation, stabilize your financial structure, and without having to spend exorbitant amounts of money in contracting new generation to compensate for losses. Rural electrification is one of the big pushes for this government right now. And something like 40 million people, and it was much higher just a few years ago, still don't have regular access to electricity. The Bangladesh Rural Electrification Board right now has, my understanding, is regulatory oversight for projects. But rural electrification has a few challenges. When you're talking about developing countries, your asset build-out in terms of poles, transformers, lines, etc., may be too expensive for remote communities. Infrastructure maintenance becomes extremely prohibitive, especially if you take into account things like floods, storms, hurricanes, etc. You'll have to put up more poles, you have to put up more wires, you have to replace your infrastructure assets. And if your local communities can't support the value of that asset, it means heavy government subsidization. Right now, there is an econometric benchmark that's been put in place by the government, and I think it's about 45,000 takas per kilometer of line in revenue that's required to sustain the asset. And if you're talking about very deprived neighborhoods or very deprived or remote communities, they may not be able to do that. Microsolar right now is being implemented as an alternative, and the smart grid approach to that would be what's called microgrids. small 10 kilowatt, 15 kilowatt systems that can actually power, based on local power consumptions, up to 150, 160. Can you hear me? Okay. 150 houses per 10 kilowatts. So these are closed-loop systems where you don't have to connect out to your regular transmission and distribution system. You can build it around the needs of the community, put in technologies that are appropriate for it, and then build out from there as your econometric metrics and measures are met. So as the community becomes richer, they can afford those lines, then you go ahead and build out the technology. Technical difficulties. One of the interesting elements is that you could try, and what this leads to opportunities for cooperative approaches to financing and maintenance, so communities can get together and cooperatively fund these projects. And it allows for the development of what you'd call prepackaged plug-and-play solutions. And the term is COTS, which means commercially off-the-shelf technology. So you're not having to reinvent the wheel. You take what's been invented out there and reapply it in the context of rural Bangladesh. Now, in case you think that this is just a developing country issue, I assure you it's not. There are power-deprived communities in North America. Aboriginal communities in northern Ontario run on generators and have very poor power supply. And microgrid technology, as I've outlined over here, are being developed as a part of that solution to ensure power stability and power quality. So this is not just what can we do in Bangladesh. This is actively being implemented in places like British Columbia and Northern Ontario. So it's proven technology. Peak flattening is it is a dry topic to say the least. And what this really refers to is when everybody goes home, at the end of the day, they turn on all their lights, they turn on their TVs, they turn on their air conditioners, and all of a sudden the demand for power goes up. And that's known as your peak load. Peak load in general has negative externalities. You could use your most expensive generators at the time, which means it's financially prohibitive. You could, if you're relying on things like oil-based generators, there are environmental impacts on it. When you apply peak load, the higher the loss factors on your line, so you're losing more energy, system efficiency goes away. And when you have peak demand outstripping your supply capacity, that's when you have load shedding, and it's a planned outage on your system, something that some of you might have experienced. Peak shifting is really the demand load side approach to decreasing energy usage during critical times. What you're trying to do is modify how energy is being used during those peak times and ensure that you transfer some of that usage to different time slots, or you flatten it from the top so that people are using less. There are two approaches. One is a very passive approach that is already being implemented in Bangladesh right across the board. It's called conservation and demand management strategies, generally revolving around energy-efficient light bulbs, appliances, some behavioral elements, so making sure you turn off your lights as you go on, etc. Those are being implemented right now. But the more dynamic side that's being considered for the West is called the more active shifting consumer behavior, but through price or information-based incentives and disincentives. So one of the elements that they talk about is commercial demand response, and I really like the idea of this, where instead of paying a peaker plant 10 cents a kilowatt hour of production, why don't you pay somebody 4 cents to turn off a light? And now you've got aggregator programs and commercial demand response programs that work not only in the residential side in Ontario, but work on the commercial and industrial side to try and aggregate this technology. And then it's actually as callable as renewable as generation. So you can call this organization, say, we want to shift peak by this many megawatts. They'll say, okay, we'll do this, we'll bid on it, and it's actually integrated into the power management structure on a 5-minute basis in Ontario. So it is fantastic. There's one element called critical peak pricing. So you give information on real-time pricing to your residential homeowners so that they can try and reduce it. Social benchmarking, which is behavioral, where you say, all right, you are using more energy than 50% or 70% of your neighbors. And using that one piece of energy, one piece of information, you can start incenting people to start moving their energy consumption down. There are many, many, many approaches to peak flattening, some of it behavioral, some of it economic, some of it technological. But all of this really access real-time data, the Internet of Things, web-based connectivity to create very dynamic opportunities for your system management. And peak management is a big deal because it's the wear and tear, it's the dollars, it's money. And there are better ways of handling your peak demand. You take care of peak demand, you can take care of a chunk of your load shedding without having to address or without having to apply more generation. System reliability, big thing, especially if you've ever gone through outages, if you've had the lights go off every so often. There are two types of outages over here. Planned, which is load shedding, unplanned, which really requires to equipment failure. System outage is a very big thing within the regulatory structure of Ontario anyways. Utilities tend to get penalized if they have too many system outages, if they're too long, and there are various metrics by which you can measure it, SAIDI, KD, MEFI, various ways of aggregating that information and taking a look at how reliable or unreliable your system is. Now, the way it works in Ontario is that if a utility has excessive outages, the regulator, the Ontario Energy Board, will start penalizing them in terms of their rate of return, in terms of how they can charge, until they fix that problem. But smart grid solutions can offer a more practical approach or a more proactive approach to solving your outage issues. First of all, it'll allow you to find the location of the outage in real time. So for that, you'd need your AMI, your advanced metering infrastructure, SCADA systems, which stand for supervisory control and data acquisition systems, fault identification systems. You can mitigate the effects of outage. So the smart grid term is self-healing grids, outage management, power quality controls, and then you can understand the cause of the outage better. Because if you understand why your system is failing at a technical level, that tells you where you need to spend money. Rather than ripping up and tearing up the entire system altogether, you can go down to the line, the bus, the transformer station, whatever is your most problematic, swap out that element to improve the reliability and the efficiency of your system. And really, that is the smart way to do it. Don't swap out your entire system. Find the problem, deal with the problem, use data to guide you, use the evidence to guide you. Renewable generation integration is, it sounds like for a lot of people, renewable generation is the way to go. But the fact of the matter is renewable generation from a grid integration standpoint can be very challenging. And I think we heard from an earlier speaker today about how a lot of wind power ended up tripping out local grid in Australia. And I know from my conversations with engineers that renewables provide little grid stability. Apart from the fact that it's not dispatchable, it's highly intermittent. A lot of wind on long feeders really affect the quality of the power over there and the system stability. If you require power stability or power quality from renewables, you have to backstop it with gas, so you negate its environmental qualities. It can pose safety issues to crews, and land requirements can be substantial, especially if you're looking at something like solar. But there are technology elements or classes of technologies that can help mitigate some of those problems, and in doing so can help reach some of your climate change targets, reduce your peak load, and enable rural electrification. Now, one of the things that's being discovered or being implemented or being developed is called a virtual power plant, and the utility in the town next to where I live in Ontario has developed a virtual power plant system which actively and proactively measures the output of utilities onto the grid and then controls it to ensure system stability. Intelligent load management systems being tested out in Newfoundland, I believe, where they're taking a look at how to better manage the integration of wind into your systems. And the most dynamic one in terms of smart grid technology is what we call blockchain technology. Software systems that allow people to trade their renewable energy output with each other. And this was being implemented, I believe, in Chicago, where an entire neighborhood used blockchain technology to say, I want clean power, how can I buy clean power? And this allowed people to set up a virtual market to buy and trade micro-scale power, and it's a phenomenal concept. Hardware elements like storage will be actually the key to renewable integration, because when storage becomes mature, it's not quite there yet, you will be able to eliminate not only your intermittence problems, but you will be able to provide reliable, renewable energy back into the grid. Of course, for developing countries, the question is, how much will all of this cost? And that is always going to be a part of your policy discussion on an ongoing basis. Greenhouse gas emissions, in some ways, I've left for the tail end, partially because I believe that if you implement smart grid proactively and in a targeted manner, lowering greenhouse gas emissions is going to be the natural outcome of it. Bangladesh, in terms of its greenhouse gas output, is actually fairly minuscule, 0.35% of global greenhouse gas emissions, but it really suffers the disproportional impact of climate change. And I think our gross output is about 150 megatons, but emissions per GDP is double of global average. That's partially because of the types of fuel sources that you use. If you use wood-burning stoves or for economic activity or wood-burning systems, you're going to emit more. There are ways, by implementing all of the technologies that I talked about earlier, whether you're doing your peak shifting, your conservation and demand management program, your critical peak pricing, your virtual power plants for renewable integration, what you would see, if properly integrated, is a net reduction, hopefully, in terms of greenhouse gas emissions. But that, of course, depends on the nature of your overall power supply mix and what your global targets are going to be. So smart grid elements from a control standpoint would be smart metering technology, smart home controls, SCADA systems, deregulating actually energy markets, right, and creating financial programs like the feed-in tariff program. This is what I'd call the planning framework. Just because you've got technology doesn't mean it's necessarily right for you, and you really need to be able to take that technology and apply it in a dedicated and targeted manner. I think we know what government directives and regulatory frameworks are. You've got your regulator over there, but really the most important bit over here is the alignment with goals and outcomes. You have to ask yourself, what is it that you're trying to do moving forward? Do you want power stability? Do you want more renewables? Do you want peak shifting or peak flattening? What are your goals? And once you've understood what those goals are, then you go ahead and then you apply the appropriate smart grid technologies that can help reach those ends or reach those outcomes. If you do not do that, you will be throwing money down the water. You apply technology, but you won't hit any of the outcomes that you're looking for. Cost-benefit analysis may seem redundant, but one of the problems that Ontario did was that it didn't fully undertake a proper cost-benefit analysis of its smart grid implementation, and it got hit by the Auditor General over there. You have to understand that just because you have that technology doesn't necessarily mean it provides you the value. So your econometric analysis, your outcomes, your deferred costs, your deferred maintenance, all of these things come together in a package, and then you have to be able to decide, is this technology worth my while against other alternatives or the status quo? And if it's a little more expensive, do I get value for my money? That econometric analysis is absolutely critical, and you cannot sidestep this bit. Capital planning. Capital planning means that you implement your technology as old technology comes off the system rather than wholesale replacement. If you want to be targeted and efficient in terms of how you implement your smart grid technology, you do it within the context of your capital planning framework, and it could be a 20-year framework. But if you know meters, your old meters are only good for 10 years, then you can say 10 years down the line, you'll do your smart grid implementation, or your smart metering, or your AMI implementation. If you find that your AMI, your advanced meters, your generation 1 meters, will no longer be equivalent or up to date 5 years down the line, once you've amortized it, then you do your next round. But throwing technology in without taking into account your planning framework, your capital planning framework, your asset management systems is not the way to go. You do it in a targeted manner. Privacy by design. This is a big one, at least in the West. I don't know how much of an issue it is over here. And my slide's a little, it's cut off here. But other elements also include security by design, because the Internet of Things, every element that you add to the grid is a potential weakness. So understanding that security and grid security in terms of your products that get attached to the grid is absolutely critical for its stability. Finally, implementation. That's when you're ready to move forward. I have a few specific recommendations for anybody who's implementing smart grid technologies, particularly within Bangladesh. Rural and urban electrification are distinct issues, and they don't treat them as the same. That was a mistake that was made in Ontario, where they tried a one-size-fits-all approach for rural energy consumers. And what they found was that they quadrupled the cost of their infrastructure costs without getting the net benefits back. So understand that your rural customers and your urban customers are not one and the same. They need distinct approaches with distinct solutions. Look at a system from end to end. This is important, because if you try and do smart grid in just one point of your grid, you won't have the awareness or the data or the information or the analytics to get the maximum effectiveness out of your system. So plan for iterative versions of smart grid. Generation 1 will have limited connectivity. It will have limited application. What comes up later on down the road may give you more value for money, but to do that, you need a planning framework that's at least 5 to 10 years in advance, so that you know once one technology is obsolete, you can start implementing the next range of technology. And for that, you need things like your working groups that can analyze some of these issues and start putting it forward. And then the one thing that I absolutely believe in is investing in your future. So research and development, X-type competitions, etc. In case you think that countries like Bangladesh can't engage in research and development, I'm going to give you the example of what's called the artificial leaf. A researcher at MIT invented a solar-powered catalyst where if you drop this thing into a gallon of water, it would produce enough hydrogen over a day to produce 200 watts of energy at night through a microburner. He took this technology, and guess who invested in it? The Tata Group out of India. They put in like $10 million. They licensed this, and the act of pouring water into a bucket, putting it in the sun, and putting this device into it is going to transform lives. So why don't we do things like that, where we identify cutting-edge technology like this, take a look at pre-commercial products, and provide that extra little bit of oomph there to own the product, license the product, ensure its commercialization and the net benefit of the country and also the world. One of the elements that I like from a research standpoint is called paint on solar. So people talk about how solar is not effective or not efficient, but what if you could paint on, and this is an actual technology, paint on a solar panel onto a pane of glass. There is technology like that. It's not quite mature yet, but imagine a city where every window generates electricity. That is amazing. Every high-rise building that comes up generates electricity passively just from its windows. You don't even have to put up solar panels. You store that, you pump it back into the grid, and you have got a dynamic system. That is the potential. This requires, however, vision. This requires the ability to plan out into the future. This requires effort. And whatever you do, think it through. Because this technology, it's not necessarily cheap, but if applied properly, will give you value for money. Thank you very much. I believe that's the end of my presentation, and the screen went blank. So that's that.
Thank you very much. Can I request the audience to give another hand of applause, because Mr. Rahman came all the way from Canada to make it happen here. Thank you very much for your excellent presentation. I just want to add, as a student of economics, I think to remind the people that, when you are talking about the efficiency, you see, first of all, in SDG Goal 7, reliability has been set as a target. So reliability is very much important nowadays. And then probably another thing that we overlook is opportunity cost of disruption, right? When there is a disruption in the system, then it has a huge opportunity cost. And if we consider then we will have to focus on digitizing our system. So now I call upon Mr. Sanjay Kumar. I think in Mr. Rahman's presentation, he talked about renewable generation integration. I think he can also give a light on the renewable generation integration. He is Executive Director of Climate Parliament.
Thank you, Chair. Honorable Ministers, my fellow panelists, ladies and gentlemen. First of all, let me thank the organizers for inviting me here in the great land of the people who are the people who were the most skilled people which made this subcontinent as the provider of 50% of the GDP during the 18th century. And that age is going to come back again because all these countries in this subcontinent are progressing so fast. And we need to applaud this movement. And we need to applaud this movement because we have here sitting Honorable Minister of Science and Technology, who saw the birth of the nation, and we have here the Honorable Minister of ICT, who is the future of Bangladesh. So, ladies and gentlemen, I'll request you to give a standing ovation and applaud to this unique moment in which we are standing here today, which is seeing the future of this country. We are actually, in Bangladesh, facing three circumstances. The first circumstance is that this country is progressing very fast. It needs a lot of energy to develop. Yeah? Energy is the key ingredient of development. It needs energy. And it needs to procure all sources of energy from different sources. From solar, from wind, from biomass, from hydro, from coal, from nuclear, from gas, from petrol, whatever. Yeah? So the energy mix of this country for energy security, about which our panelists were talking, is quite diverse. It's based on a diverse set of fuels. And that creates a lot of challenge. Yeah? The second set of circumstance is that, as our keynote speaker has mentioned, that the losses in Bangladesh power system, both because of technical issues, transmission losses, distribution losses, and commercial losses are quite large as compared to many other countries. And the third circumstance, which our chair just mentioned, the opportunity cost of not having power, even for a moment. What is that opportunity cost? And I didn't come prepared for this, but I have some figures to tell you. And this is about the survey of small and medium enterprises in Bangladesh which the World Bank undertook in 2006. As per that survey, although it's slightly dated, but I think that it holds true even today, is that there are about 3 million SMEs, small and medium enterprises in Bangladesh, which face, on an average, 64 power cuts a month. That situation might have improved. I'm talking of 2006, but the situation might not have completely reversed. And the average power cut duration is 1.2 hours, and which is affecting the output to the tune of 5.5%. So small enterprise, a medium enterprise in Bangladesh is facing an output loss of 5.5% only on account of power interruptions, unscheduled power interruptions. Scheduled power interruptions may cause slightly lower loss, but unscheduled power loss cause a lot of loss. And as a result, 64% of Bangladesh SMEs, they own generators. And the cost of generation of power from generators, as you know, is much higher as compared to the grid-connected power. So when the whole global economy is actually working on 2 to 3% profit, if Bangladesh enterprise is facing a loss of 5.5% only on account of power interruption, you can understand what is the kind of opportunity loss which our chairperson was talking about. Yeah? And this kind of a loss, when we are growing very fast, when our energy sources is diverse, solution is that we need to interconnect bidirectionally. So our keynote speaker was mentioning every organization, every place has to become prosumer. It has to produce, it has to consume, yeah, at the same time. But how do you actually balance out the production and the consumption from different sources, different types of demands? You need a very smart system. And that smart system actually, the keynote speaker talked about large systems, but what I'm going to show to you is how you can do it actually at the village level. Can someone help with the slides, please? Yeah, sorry. Is what the developers of this small village mini grid in India are claiming that they are the world's first smart nano grid. Nano is smaller than mini or micro. So it's very small. It is catering to a village of about 150 households. And it is smart because it is integrated with a communication system all through. So what the developers have done actually is to have a VSAT-based communication system in a remote village where there is no connectivity, no grid, nothing, no system. And because it is deep inside the forest, so you cannot have the fiber optic network as well, or these big microwave towers, because it's situated right inside a tiger sanctuary. So they have a VSAT system which connects each and every household. So what is there? That the whole system in this village is being monitored live. And I think this is live data, and it can show, for example, this particular consumer has used today, yeah? Whether, and say, for example, whether this irrigation pump is active or not. How much is, for example, today's generation from the solar power plant is not working today. Yeah? But, for example, whether the server is working or not. So each and every load is being monitored remotely on a live basis. And this gives actually the tool with which an engineer sitting 400 kilometers away in the state capital can remotely manage and find out that what is the actual fault, what is going to be the demand, what is going to be my generation, and all these things. And this is also allowing actually a lot of savings which can be used, the energy savings, which can be used by the enterprises. And enterprises, if we are giving energy to the local enterprises, then it is becoming much more profitable. That's, the whole system is becoming sustainable financially. Yeah? And this is also being linked now to what is being called Digital India, which is a counterpart of Digital Bangladesh. So now the government is planning that instead of the certificates, for example, which are being issued at the district offices or the subdivisional offices, they could be issued digitally in the village itself. It is also enabling what we call remote health system management. So a patient here now sitting in the village, he doesn't need to go to the district hospital or to the state hospital for the treatment. A specialized advice is available because of the system that the health choice system is available right in the village itself. So this is creating a completely new opportunity. And this new opportunity is coming about through this smart grid system, which is not only at the national level, but down to the village level. Yeah? And finally, I will end up with this, is that this whole system actually will be a system which could transform a country. It's not only going to be the combination of the power system, the information system, and the services which are to be made available at the local level, but also a completely new type of economy. I'll end it with, thank you very much.
Thank you, Mr. Kumar. Our distinguished panelists are here. You can actually talk from here. So now I invite Mr. Jamil Azhar, Chief Strategy Advisor, Startup Bangladesh project, just to give a bit of housekeeping. After the panelists, talk, we will Q&A, and we already have questions. And apart from that, if there are any further questions, then we will do. But we have to remember that our next seminar will start at 4. So we have almost an hour, but we want to finish it a bit earlier. And again, thanks to the audience, maybe my eyesight is gone, but I don't see any drowsy face after the lunch. So thank you very much for listening. Now I invite Mr. Azhar. You can speak from here if you want. You have the... Okay, thank you.
Can everybody hear me? Yes, thank you. Thank you, sir. Thank you. Thank you very much. I appreciate it. Honorable ministers, esteemed dignitaries, and respected ladies and gentlemen. Is my volume okay? Is this the right volume? Yeah, thank you. So initially, I was going to talk to you about IoT and smart grid. But after talking to Honorable Minister for Science and Technology, I changed my speech a little bit. I'm going to talk about young people, digital Bangladesh and smart grid. And you may be thinking, how are these things related? So bear with me for 5 minutes. I shall show you how these things are all related and smart grid will create huge business opportunities for you as well as for the country in 5 minutes. So let's take a step back. What is a smart grid? We heard from the esteemed keynote speaker. The smart grid basically means you have smart components everywhere, right? So essentially in my brain, it is a combination of electrical engineering and computer science, right? 20 years ago, there was electricity, but no computer science. And then computer science came and nothing to do with electricity. So now you have a marriage between computer science and electrical engineering, which is at least a 100-year-old technology, in the form of smart grid. That is the basic, that is the essence. These are called, technically speaking, cyber physical systems. Cyber physical systems. You control machines using IT. This is the fundamental concept of smart grid. Now, how is Bangladesh grid going to become smart? This is where opportunity for all of you in the room comes. We heard IoT, Internet of Things, is going to play a very big role in smart grid. Why? Because every single thing on the smart grid is essentially an IoT device. Now, without getting into complicated engineering subject, you will have three issues, three things you have to think about when you try to put IoT on top of smart grid. Number one, capacity. Number two, capability. And number three, security. Give me 1 minute. I'll explain each one of them in under a minute. Capacity. Imagine each and everybody in this room, all of you are smart meters. And I am the server. You guys are all smart sensors. In a smart grid, in a true smart grid, if each of you starts sending a data packet to me every single second, very soon what's going to happen? The network will be saturated, right? Because all of you try to speak to me at the same time. I don't have the capacity. I don't have the network capacity. I don't have the storage capacity. I don't have the analytical capacity. So we will have to build those capacities as part of the ecosystem in order for the grid to become smart and IoT to become successful. This will require a lot of investment, lot of intelligence, lot of innovation. And perhaps the private sector can participate in that innovative process. Capability. Once all of you send me data, I will then have to analyze the data. And this is too much data for me. You cannot store it in a database. So then things like artificial intelligence, big data, those systems will have to be implemented on the smart grid. Opportunity for you to create innovation and differentiation, right? Third is security. Security will become extremely important. Just 2 months ago, in October, I was in the US, there was one of the largest cyber attacks in US history that took down the internet. Amazon was down, Netflix was down, Twitter was down, half of American internet was down. You know how it was, where it came from? It's all over the news. It came from IoT devices, cameras connected to the internet, DVRs. One company's CCTV system, not one company's, one manufacturer's CCTV system was hacked. Classic IoT attack. Half of internet in America went down. So imagine that happening on the smart grid. So a lot of innovation, intelligence will have to be put into the smart grid in order to ensure security. So to help the young generation do all of these things, be part of the digital future, Honorable Minister, ICT Minister has created a new initiative called Startup Bangladesh, where we shall nurture entrepreneurs, young people, we shall foster innovation. You heard from the keynote speaker, one of the new technologies is blockchain. That's going to enable smart meters, smart dynamic pricing, smart billing. We will be incubating that in the accelerator. So under the ICT Ministry, we have a program, Talk to Us. This will become public very soon. But that will be the crucible where we foster innovation for a better digital future of Bangladesh. Thank you for your time.
Thank you very much. Now I invite Mr. Mahbub Zaman, Managing Director, Datasoft Systems Bangladesh Limited, for his comments.
Thank you very much. Actually, it is a great pleasure that it is a very timely event, which is really the total nation is requiring, and there are number of pleasant combinations, because I find that there is State Minister for Science and Technology, State Minister for ICT, also Minister for Energy and Power, expert from non-resident Bangladeshi, Canadian Bangladeshi, who is expert in this, and also the experts from the industry and also private industry. This combination actually does not happen. Sometimes for this lack of combination, we do not find the proper proper result of the sessions and seminars. Thanks very much to Mr. Namir Rahman for an excellent presentation, and I believe that that presentation will help us a lot. Actually, till recently, we are all internet connected. Almost, I think that whoever sitting here is almost everyone is internet connected, and this is changing our lifestyle with the mobile and internet penetration. Since recently, actually, we were connected. Maybe I was connected with Yafes Osman, Yafes Osman was connected with Nasir, Mr. Bipu, or Mr. Bipu was connected with Junaid Ahmed Polok, and it was human to human. But recently, it has changed. The internet has become object to object. That means your mobile phone is commanding your refrigerator to get on or not. Your smart meter is giving you the information that you are consuming much electricity. Your refrigerator is commanding you when you are at Agoro or Mina Bazar that you are lack of eggs or chicken. You will have to buy that. So now the total scenario is changed. So this Internet of Things has really changed the total global scenario. And thanks to the organizer, that the subject matter of today is a combination of smart grid, Internet of Things, and digital Bangladesh. Because the vision of digital Bangladesh has changed the total scenario in Bangladesh, the total economic fabric of Bangladesh, and also the mindset of Bangladesh. And that is why actually we are discussing about smart grid. Just I will show you a 2 minutes video that will give you that what is the idea of this smart grid and how it is connecting with IoT and how it is connecting with digital Bangladesh. Because digital Bangladesh vision has given us the responsibility to act like a changing the lifestyle in a digital way for the benefit of the people. So actually we are ready for this change, and already I find a paper which was part of this seminar. It says that we have started with smart meters, which is giving us the reading. It is giving us the reading of this, the different areas. Already 46,000 smart meter is being installed by BP Power Development Board. DESCO has already installed number of smart meters. But we are discussing about.
The video is ready whenever you say it again.
Yeah. So we can start the video if it is ready.
Today's Central Station-controlled power grids operate on update cycles that are as long as 15 minutes. Every 15 minutes, the central station estimates the power and adjusts its generators to meet the load. Unlike traditional sources of energy, renewable power sources such as solar panels or wind turbines don't have a predictable output over the same time range. Fast loads, like plugging in your electric car, are also hard to predict. If the grid drops below the needed power, it can fail. So, to ensure sufficient power, grid operators maintain extra power plant reserves to compensate for these fluctuations. That keeps the lights on, but it wastes fossil fuels. It means the renewables are not lowering the carbon footprint as much as they should. To deliver on the promise of renewable energy, the Industrial Internet Consortium, IIC, started a new initiative named the Communication and Control Testbed for Microgrid Applications to enable the efficient use of renewable energy resources at a large scale. This is an ambitious goal. But when the expertise and the technology come together, the dream can become a reality. The Industrial Internet of Things provides a disruptive technology that will change the way the grid operates. 3 members of the IIC are lending their expertise to the Microgrid Communication and Control Testbed project. RTI is providing the real-time data bus software. National Instruments is providing the intelligent nodes for edge control and analytics. Cisco is providing network equipment and security expertise. The Open FMB project at the Smart Grid Interoperability Panel is defining communications data model and services standards. Duke Energy, Southern California Edison, and CPS Energy will take the architecture through performance and security testing to prepare it for real-world challenges. The goal of the new initiative is to prove the viability of real-time communications and control framework which combines distributed, edge-located processing and control applications with intelligent analytics. A real-time secure connectivity framework enables machine-to-machine, machine-to-control center, and machine-to-cloud data connectivity. The framework will run in real-world power applications and interface with operational equipment. At the core of the new smart microgrid critical infrastructure is a high-speed field data bus that connects devices and intelligent nodes. The data bus also interacts with the central station and the cloud, taking advantage of both local and remote state to optimize operations. The data bus streamlines the delivery of real-time data to analytics to any node on the network, edge, or cloud. It is based on the Data Distribution Service Protocol, DDS, the first open international middleware standard for industrial internet systems. Unlike other connectivity protocols, DDS is data-centric. Imagine a database in motion, zooming at extremely high speed and securely sharing massive amounts of data across any number of highly distributed and heterogeneous systems. The data bus leverages the industry-leading unique publish-subscribe peer-to-peer connectivity platform, RTI Connext DDS. It operates without a centralized message broker with high efficiency. It ensures data gets to where it needs to be, on time, making the smart grid infrastructure interoperable, resilient, scalable, and secure.
So this is all what I wanted to tell you, that this is secured, this is real time, this is all, everything is connected. It is sharing the load and distribution and transmission. Within this distribution and transmission, there is no wastage of energy. This paper says that between generation, transmission and distribution, we are losing almost 1/3 of the total energy. So that is 30%, which is about $247 million per year. And also a study says that if we move to smart grid, that will be costing in the developed country, it costs about 2.47% of the total energy generation and transmission. And in developing countries like ours, in Bangladesh, it will cost us 3.1%. So now we will have to decide whether we will be losing 33% or we will be investing 3.1% to stop that wastage. So that is the real world now, and we can only offer that our industry is not ready for the total smart grid, but we can have a pilot project, and specifically I can propose to ICT State Minister and Science and Technology Minister and also Energy Power Ministry that if we can combine all these things with private sector, we can have a pilot microgrid in Bangladesh, even in Dhaka, even a part of Uttara, which will change the total scenario. You will be getting all the information at your palm top about, and also we'll be sharing because we propose Uttara because there is a commercial portion and residential that can share the total energy also. So that is how we can start with the microgrid, and that will be the start of the smart grid in Bangladesh. And last but not the least, I find a lot of young people here in the backside of this audience. Actually, this is our historical responsibility. We tell that Bangladesh is now at the stage of demographic dividend, where 66% of the population is under age 28. And here sitting is one of the renowned valiant freedom fighter, Yafes Osman. I was co-fighter with him. So we, at that time, we are at the age of yours, that means 20, 21, 22. So we could fight for the nation. We could show our patriotism. We could prove our patriotism through a liberation war and after the victory of the liberation war. But Junaid Ahmed Polok is now the new freedom fighter, that means new liberation warrior, who can achieve electricity. Nasrul Hamid Bipu, he can achieve electricity, and that is our second liberation war. So we think that you are all Mukti Jodhas, you are all freedom fighters, and you will have to do this thing. It is the liberation war of this time, and we are fortunate that we are in that age group, generation. We could liberate our country. Now it is your responsibility to go ahead with electricity, smart grid, and industrialization. Thank you very much.
Thank you, Mr. Mahbub Zaman. Now I humbly request Mr. Junaid Ahmed Polok, MP, Honorable State Minister for ICT, Government of the People's Republic of Bangladesh, to say a few words.
Thank you, Mr. Chair, for your great introduction, and thank you very much for inviting me to join this session. And we have with us from Climate Parliament, Mr. Sanjay, our IT expert and keynote speakers, and especially our Honorable Minister of Science and Technology. And distinguished ladies and gentlemen, good afternoon to you all. I'm going to speak in Bangla. আমি প্রথমেই শ্রদ্ধাভরে স্মরণ করছি এই বিজয়ের মাসে জাতির জনক বঙ্গবন্ধু শেখ মুজিবুর রহমানকে এবং ৭১-এর মহান মুক্তিযুদ্ধে যে ৩০ লাখ শহীদের আত্মদানের বিনিময়ে ২ লক্ষ মা বোনের সম্ভ্রমের বিনিময়ে আমরা একটি স্বাধীন সার্বভৌম বাংলাদেশ পেয়েছিলাম। সেই সকল শহীদের আত্মার প্রতি আমি বিনম্র শ্রদ্ধা নিবেদন করছি। আজকে আসলে স্মার্ট গ্রিড এবং ইন্টারনেট অফ থিংস, এই যে বিষয়টি নিয়ে আজকের যে সেশন, আমরা প্রেজেন্টেশন দেখেছি, বক্তব্য শুনেছি এক্সপার্ট বৃন্দের। তো এখানে আপনাদের হয়তো প্রশ্ন আসতে পারে যে এখানে আইসিটির কি কাজ। আসলে এই মুহূর্তে আমরা যদি তথ্য ও যোগাযোগ প্রযুক্তি এই বিষয়টি নিয়ে আলোচনা করতে যাই, তো আইসিটি হচ্ছে একটি ক্রস কাটিং ইস্যু, যেটার আসলে ব্যবহার সর্বত্রই রয়েছে। এবং এই ডিসেম্বর মাসেই 2008 সালে মাননীয় প্রধানমন্ত্রী জননেত্রী শেখ হাসিনা 2008 সালে ডিজিটাল বাংলাদেশের রূপকল্পটি দিয়েছিলেন, প্রথমবারের মতো একটি দীর্ঘ মেয়াদি একটি রূপকল্প আমাদের দেশ এবং জাতির সামনে। এবং সেটি ছিল মূলত আমাদের এই প্রযুক্তির পথে, প্রগতির পথে এগিয়ে যাওয়ার প্রথম আমাদের স্বপ্ন দেখার একটি সুযোগ করে দিয়েছিলেন জননেত্রী শেখ হাসিনা। এবং তারপর থেকেই আমরা 2009 সাল থেকে মাননীয় প্রধানমন্ত্রীর সুযোগ্য সন্তান, আর্কিটেক্ট অফ ডিজিটাল বাংলাদেশ জনাব সজীব ওয়াজেদ জয়ের সুপরামর্শে এবং তত্ত্বাবধানে আমরা ডিজিটাল বাংলাদেশের অগ্রযাত্রা শুরু করেছিলাম। এবং শুরুতেই যেই ব্যক্তি, যেই নেতা আমাদেরকে এই বাস্তবায়নে সবচেয়ে বেশি ভূমিকা রেখেছিলেন, উনি আজকে আমাদের সামনে মঞ্চে উপস্থিত আছেন, যিনি সায়েন্স এবং টেকনোলজি মিনিস্ট্রি তখন একত্রিত ছিল। এখন যদিও আইসিটি মিনিস্ট্রি আলাদা হয়েছে, কিন্তু মূলত আইসিটি পলিসি, আইসিটি সাবজেক্টটাতে কারিকুলামে অন্তর্ভুক্ত করা, হাইটেক পার্ক অথরিটি আইন প্রণয়ন করা, এই প্রত্যেকটি কাজের সূত্রপাত যার হাত দিয়ে হয়েছিল, উনি হচ্ছেন আমাদের প্রিয় নেতা, আমাদের প্রিয় মন্ত্রী জনাব স্থপতি ইয়াফেজ ওসমান। তো আমি তার সম্মানে একটি সবাইকে জোরে করতালি দিয়ে অভিনন্দন জানানোর জন্য অনুরোধ করছি। আমি জানি যে এই শীতের দুপুরে সবাই দুপুরে খাওয়া দাওয়া করার পর সবাই একটু ঝিমুনি আসছে। আসলে এখন বক্তব্য শুনতে খুব একটা ভালো লাগবে না। তো প্রথমেই একটা বিষয় বলতে চাই, আপনাদের কাছে স্মার্টফোন কার কার কাছে আছে? একটু হাত তুলবেন। স্মার্টফোন একটু দেখাবেন, বের করে কার কার আছে, সবাই একটু হাত তুলে। আচ্ছা, চমৎকার। অনেকে দুটা করে হাত তুলেছেন, কেন? কারণ দুইটা করে আছে, রাইট। তো এখন আমাদের দেশে 3 কোটি স্মার্টফোন, 3 কোটি স্মার্টফোন, 6 কোটি 40 লাখ ইন্টারনেট ইউজার। কিন্তু এই অবস্থা তো আগে ছিল না। যখন ফিলোসফি অফ রিভলিউশন ডিজিটাল বাংলাদেশ রূপকল্পটি জননেত্রী শেখ হাসিনা দিলেন দেশ এবং জাতির সামনে, তখন আপনাদের নিশ্চয়ই মনে আছে, তখন অনেকেই হাসাহাসি করেছেন যে বাংলাদেশে 2008 সালে বিদ্যুৎ ব্যবহারকারীর সংখ্যা ছিল মাত্র 100 জনে 42 জন, অর্থাৎ মাত্র 40%-এর কাছাকাছি, তাই না? আর ইন্টারনেট ইউজ করত মাত্র 10 থেকে 12 লাখ মানুষ। 3 কোটি 4 কোটি মোবাইল ফোন ইউজার ছিল। কিন্তু মাত্র 8 বছরের ব্যবধানে মাননীয় প্রধানমন্ত্রী জননেত্রী শেখ হাসিনার ডাইনামিক লিডারশিপের কারণে, অক্লান্ত পরিশ্রমের ফলে এবং দূরদর্শী নেতৃত্বের কারণে আজকে কিন্তু আমরা প্রায় 78% মানুষ বিদ্যুৎ ব্যবহার করার সুযোগ পাচ্ছি। এবং যেই বিদ্যুৎ ছাড়া আমাদের ডিজিটাল বাংলাদেশ, আধুনিক প্রযুক্তি ব্যবহার প্রায় অসম্ভব। আমাদের ইন্টারনেট ইউজারের সংখ্যা বেড়ে দাঁড়িয়েছে 6 কোটি 40 লাখ। মোবাইল সাবস্ক্রাইবার 13 কোটি ছাড়িয়ে গেছে। স্মার্টফোন ইউজার 3 কোটি ছাড়িয়ে গেছে। সোশ্যাল মিডিয়া ইউজার, শুধু ফেসবুকের ইউজারের সংখ্যা 2 কোটি ছাড়িয়ে গেছে। আজকে যে এই যে প্রযুক্তির যে দ্রুত পরিবর্তন, এইটার সাথে যদি আমরা খাপ খাওয়াতে না পারি, তাহলে আমরা বিশ্বের সাথে তাল মেলাতে পারবো না। আজকে স্মার্ট গ্রিডে যে কথাটি বলা হলো, আমার দৃষ্টিতে মনে হয় যে এই মুহূর্তে বিশ্বের যতগুলি ডিভাইস আছে, অনেকেরই ভবিষ্যৎবাণী যে প্রায় 5 বিলিয়ন ডিভাইস will be connected by 2020. তো এই যে 5 বিলিয়ন ডিভাইস একজন আরেকজনের সাথে সম্পৃক্ত হবে, ঠিক একইভাবে এখন যেরকম পাওয়ার গ্রিড ম্যানেজমেন্ট সিস্টেম প্রয়োগ করে প্রত্যেকটা পাওয়ার প্ল্যান্ট একটার সাথে আরেকটার কখন কোনটা অন থাকবে, কোনটা অফ থাকবে, সেটি যেরকম নিশ্চিত করছে, সেরকম আরও দ্রুত প্রযুক্তি পরিবর্তন হচ্ছে, প্রত্যেকটি ব্যবহারকারী আস্তে আস্তে সংযুক্ত হবে। স্মার্ট গ্রিড হচ্ছে বিদ্যুৎ এবং প্রযুক্তির একটি সমন্বয়। কারণ আমরা লক্ষ্য করে দেখছি এই যে হল রুম, এখানে এতগুলো লাইট জ্বালানো আছে। আপনারা কি মনে করেন যে এই মুহূর্তে এই শত শত লাইট এখন অন থাকার কোনো দরকার আছে? কি মনে হয় আপনাদের? আমাদের তো ডে লাইট আছে, সূর্যের আলো আছে, কিন্তু ওই যে সকালে হয়তো 8টার সময় যখন এই হল রুমটা খোলা হয়েছে, তখন যে লাইটগুলো অন করা হয়েছে, তারপরে কিন্তু আর লাইটগুলো অফ করা হয়নি। কিন্তু যদি এখানে স্মার্ট সেন্সর থাকতো, যদি ইন্টারনেট অফ থিংস থাকতো, যেটা দিয়ে এই প্রত্যেকটি লাইটে, প্রত্যেকটি বাল্বে, প্রত্যেকটি এলইডি হোক বা এনার্জি এফিশিয়েন্ট লাইট হোক, সেটাতে যদি সেন্সর সেট করা থাকতো, তাহলে কি হতো? এখানে আলোর পরিমাণ যত বাড়তো, প্রত্যেকটি লাইট অটোমেটিক্যালি কিন্তু অফ হয়ে যেতে পারতো। ঠিক যেরকম আমাদের সোলার পাওয়ার্ড স্ট্রিট লাইটগুলো হয়। সূর্য যখন অস্ত হয় কিংবা আকাশ যখন মেঘাচ্ছন্ন হয়, যখনই অন্ধকার নামে, তখন স্বয়ংক্রিয় পদ্ধতিতে স্ট্রিট লাইটগুলো জ্বলে ওঠে। এখানে যদি এই বসুন্ধরা কনভেনশন সিটিতে আমরা এই যে কয়েকশো আলো বাতি আছে, এইটাতে যদি আমরা স্মার্ট টেকনোলজি যদি আমরা অ্যাডাপ্ট করতাম, তাহলে কি হতো? তাহলে এখানে পাওয়ার কনজিউমটা আমরা এফিশিয়েন্টলি হ্যান্ডেল করতে পারতাম। ছোট্ট একটা উদাহরণ, এই রকম বাংলাদেশে পৃথিবীতে বিলিয়ন্স ডিভাইস অপ্রয়োজনে জ্বলছে। এরকম শত শত হাজার হাজার মেগাওয়াট বিদ্যুৎ অপচয় হয়ে, কিন্তু আমরা যদি স্মার্ট গ্রিড ম্যানেজমেন্ট সিস্টেমটা ইন্ট্রোডিউস করতে পারি, আমরা যদি ইন্টারনেট অফ থিংস সঠিকভাবে যদি আমরা প্রয়োগ করতে পারি, তাহলে যেই কথাটা আলোচনা হচ্ছিল যে বাংলাদেশে 30% যে সিস্টেম লস হচ্ছে, আমরা 14-15% সিস্টেম লস করছি, এর ফলে আমাদের ব্যয় বাড়ছে প্রায় 30%। কিন্তু যদি স্মার্ট গ্রিড আমরা যদি অ্যাডপ্ট করতে চাই, আমরা যদি ইন্টারনেট অফ থিংস যদি আমাদের স্মার্ট গ্রিডে সম্পৃক্ত করতে চাই, তাহলে টোটাল কস্টের আমাদের 3% এক্সট্রা আমাদেরকে বিনিয়োগ করতে হবে। তাহলে বলুন, 30% বেশি নাকি 3% বেশি? নিশ্চয়ই 30% বেশি। তো 30% খরচ আমরা কমাতে পারি যদি 3% অতিরিক্ত আমরা বিনিয়োগ করি। তাহলে আমাদের যত ইনফ্রাস্ট্রাকচার তৈরি হচ্ছে, সেইটাতে যদি আমরা ট্র্যাডিশনাল প্রযুক্তি ব্যবহার করি, তাহলে আমাদের খরচ, অর্থাৎ এই যে লাইটগুলো জ্বলছে অকারণে, কে আছেন এখানে ম্যানেজমেন্টে? একটু দয়া করে লাইটগুলো অফ করেন তো দেখি লাইটে কি হেরফের হয় সিলিংয়ের। দেখি কয়েকটা গ্রুপ অফ করে দেখেন কীরকম হেরফের হয়। আমার মনে হয় অনুষ্ঠানটা খুব বেশি সমস্যা হবে না যদি আমরা সিলিংয়ের এই আলোগুলো বন্ধ করি। কারণ মাননীয় প্রধানমন্ত্রী সবসময় বলেন যে আমাদেরকে সংযমী হতে হবে। আমাদের পাওয়ার প্রোডাকশন যেরকম বেড়েছে 3200 মেগাওয়াট থেকে 15,000 মেগাওয়াট, আজকে আমরা 5:30টার পরে আলোক উৎসব করছি হাতের ঝিলে। এই যে আলোক উৎসব করতে পারছি, এই যে 15,000 মেগাওয়াট আমরা উৎপাদন করলাম, যদি আমরা আরেকটু অপচয় রোধ করি, আরেকটু যদি আমরা সংযমী হই, তাহলে কিন্তু আরও হয়তো কয়েক লাখ বা কয়েক কোটি মানুষকে আমরা এই বিদ্যুতের আওতায় নিয়ে আসতে পারবো। তো এই একটা বাস্তবসম্মত প্রযুক্তি আমরা যদি ব্যবহার করতে পারি, চিন্তা করে দেখুন এই যে পর্দাগুলো আছে, এই যে আমাদের এই যে হল রুমের যে পর্দা, ওই যে সামনে এই পর্দাগুলো ধরুন যখন দুপুরবেলা কড়া রোদ ছিল তখন এই পর্দাটার দরকার ছিল, ঠিক না? কিন্তু এখন রোদটা অনেক কমে গেছে, এখন কিন্তু খুব একটা আলো আসছে না। তো এখন এই পর্দাটা যদি আমরা উঠাতে পারি তাহলে কিন্তু অনেক বেশি আমরা আলো পাবো, কিন্তু আমাদের খুব একটা সমস্যা হবে না। কিন্তু সেই পর্দাগুলো কে তুলবে? এর জন্য আরও 5 জন লোক নিয়োগ করতে হবে। আর যদি আমাদের আধুনিক প্রযুক্তি ব্যবহার করতাম, যদি সেখানে আমরা ইন্টারনেট অফ থিংস আমরা ব্যবহার করতাম, আমাদের স্মার্টফোনে যদি আমরা কন্ট্রোল করতে পারতাম যে এই একটা স্মার্টফোনে এখন আমি একজনকে ডাকলাম যে ভাইয়া যাও, যে সুইচটা অফ করো, তবে এই লাইটগুলো বন্ধ হবে, নাহলে কিন্তু হবে না। কিন্তু এইটা করা সম্ভব একটা স্মার্টফোন দিয়ে। স্মার্টফোনে একটা অ্যাপ্লিকেশন থাকবে, সেই অ্যাপ্লিকেশনের সাথে এই পুরো এই হল রুমের যতগুলো পর্দা, যতগুলো দরজা, যতগুলো লাইট আছে সবগুলোকে কিন্তু কন্ট্রোল করা সম্ভব একটা মোবাইল ডিভাইস দিয়ে। এটাই হচ্ছে ইন্টারনেট অফ থিংস। অর্থাৎ প্রত্যেকটি ডিভাইস ইন্টারনেটে সংযুক্ত থাকবে, এবং এটা কোনো সায়েন্স ফিকশন, কোনো অলৌকিক কোনো গল্প না, এটা বাস্তবতা। এখন এই পৃথিবীতে, এই বাংলাদেশে আমাদের অনেকগুলো কোম্পানি এটা করছে, যেরকম ডেটাসফট। তারা বাংলাদেশের পায়োনিয়ার অটোমেশনে আমাদের প্রায় প্রায় 10,000 কোটি টাকার অতিরিক্ত রেভিনিউ আর্ন করেছে আমাদের চিটাগাং পোর্ট, শুধুমাত্র অটোমেশনের ফলে। 5 বছর পরে তারা বিওটি পদ্ধতিতে সেই চিটাগাং পোর্টের অটোমেশনকে তারা সাকসেসফুলি কমপ্লিট করে তারা হ্যান্ডওভার করে দিয়েছে। তো 10,000 কোটি টাকা আমাদের রেভিনিউ যারা বাড়ালো, তাদের জন্য একটা জোরে করতালি কি আমাদের দেওয়া উচিত না? চিন্তা করে দেখুন, এই যে যত আমাদের ইম্পোর্ট হয়, এইটা একদিকে যেরকম সময় কমিয়েছে, আরেকদিকে আমাদের রেভিনিউ বাড়িয়েছে। ঠিক একই রকমভাবে দেখুন, প্রায় 5 মিনিট পার হয়ে গেল, একটা লাইটও কিন্তু অফ হয়নি। কারণটা হচ্ছে আমাদের এখানে হিউম্যান ইন্টারভেনশনের দরকার। অর্থাৎ 2 জন খুঁজছে, যাদেরকে আমি নির্দেশ দিয়েছি, অনুরোধ করেছি, সে হয়তো জানে না লাইটের সুইচ কোথায়, তাই খুঁজতেছে। এই খুঁজতে খুঁজতে আরও 10 মিনিট আরও অতিরিক্ত লাইট খরচ হবে, আরও ইলেকট্রিসিটি নষ্ট হবে। কিন্তু যদি এটা স্মার্ট ম্যানেজমেন্টের মধ্যে থাকতো, তাহলে কিন্তু অটোমেটিক বিকাল 3টার পরে ওই পর্দাটা উঠে যেত, লাইটটা বেড়ে যেত, আর ওপরের এই আলোগুলো বন্ধ হয়ে যেত। তো এইভাবেই কিন্তু আধুনিক প্রযুক্তি আমাদের জীবনকে যেরকম সহজ করেছে, আমাদের খরচ কমিয়েছে, এবং আমাদের পরিবেশেরও সহায়ক ভূমিকা পালন করেছে। হয়তো খুব অল্প সময়ের মধ্যেই এমন কিছু প্রযুক্তি আবিষ্কার হবে যে হয়তো আমরা অফিসে, কর্মক্ষেত্র থেকে বাসায় যাওয়ার আগেই হয়তো আমরা মোবাইল ফোনে অর্ডার করে দেব যে একটা রাইস কুকার কিংবা একটা অটোমেটেড রুটি বানানোর মেশিন আপনার জন্য, ঠিক আপনি যখন বাসায় পৌঁছাবেন তখনই গরম গরম ভাত অথবা গরম গরম রুটি একেবারে ভেজে আপনার টেবিলে হাজির করে দেবে। তো প্রযুক্তির এইরকম ব্যবহার কিন্তু হচ্ছে, গবেষণা হচ্ছে। আমরা আইসি ডিভিশন থেকে ইনোভেশন, ডিজাইন অ্যান্ড এন্টারপ্রেনারশিপ একাডেমি একটি মাননীয় প্রধানমন্ত্রী জননেত্রী শেখ হাসিনা অনুমোদন দিয়েছেন, যেখানে আমরা 8টি ক্যাটাগরি ডিসরাপটিভ টেকনোলজি, কাটিং এজ টেকনোলজি নিয়ে আমরা গবেষণা করছি। আমরা আইসি ডিভিশন থেকে যে কোনো ধরনের আমাদের তরুণ যারা উদ্যোক্তা আছেন, উদ্ভাবন এবং আইডিয়া আছে, সেগুলোকে আমরা সিড ফান্ড দেওয়া, তাদের রিসার্চ এবং তাদের প্রোডাক্ট ডেভেলপমেন্টের জন্য তাদেরকে টেক মেন্টরিং, তাদেরকে নার্চার করা, এবং তাদের মিনিমাম ভায়াবল প্রোডাক্টগুলিকে কমার্শিয়ালি নিয়ে যাওয়া, গ্লোবালি নিয়ে যাওয়ার জন্য আমাদের সর্বোচ্চ সহযোগিতা থাকবে। তো আজকে আমি আবারও ধন্যবাদ জানাচ্ছি বিদ্যুৎ এবং জ্বালানি মন্ত্রণালয়কে এরকম চমৎকার একটা আয়োজন করার জন্য, এবং আমরা আশা করি যে আমরা সারা বিশ্বের কাছে একটি শুধুমাত্র নিম্ন মধ্যম আয়ের শ্রমজীবী জাতি হিসেবেই নয়, 21 সাল নাগাদ বঙ্গবন্ধুর স্বপ্নের সোনার বাংলাদেশের আধুনিক রূপ জননেত্রী শেখ হাসিনার ডিজিটাল ইকোনমির উপরে দাঁড়িয়ে একটি নিম্ন মধ্যম আয়ের দেশ থেকে মধ্যম আয়ের একটি উন্নত আধুনিক প্রযুক্তি নির্ভর বাংলাদেশ হিসেবে বিশ্বের কাছে পরিচিত হতে পারব। সবাইকে ধন্যবাদ। জয় বাংলা, জয় বঙ্গবন্ধু।
Thank you, sir, for your stimulating speech. I think, he has demonstrated so beautifully is that although that person went there, but he could not figure it out how to switch off the lights. So I think that's an extraordinary demonstration of how Internet of Things work. So now I humbly request Honorable Minister, Architect Yafis Osman, Honorable Minister for Science and Technology, for his valuable speech. Thank you.
মঞ্চে উপবিষ্ট জুনায়েদ আহমেদ পলক, প্রতিমন্ত্রী আইটি মন্ত্রণালয়, দেশের এবং বিদেশের এক্সপার্ট সমূহ এবং আমার সামনে উপস্থিত ভাই ও বোনেরা আমার, প্রথমে আমি ইলেকট্রিসিটির ব্যাপারে বলতে চাই যে এনার্জি বা ইলেকট্রিসিটি এমনই একটা জিনিস যেখানে সোশ্যালিস্ট আর ক্যাপিটালিস্টের মধ্যে কোনো তফাৎ নেই। উভয়েই কিন্তু মনে করে যে আপনার ইলেকট্রিসিটি বা এনার্জি ছাড়া যে যেভাবেই চায় না কেন মানুষকে সেবা দেওয়া যায় না। এবং সেই জায়গায় আমি বলবো বিগত 7-8 বছরে 7 বছরে আমি বলবো বাংলাদেশ যেখানে গেছে, আজকে আপনারা যেই ধরনের ইলেকট্রিসিটি পাচ্ছেন, এটা সবচেয়ে বড় প্রাণশক্তি যার, তিনি হলেন বঙ্গবন্ধু কন্যা জননেত্রী শেখ হাসিনা। উনি প্রথমেই বলেছিলেন যে আমার মানুষকে যদি আমি ইলেকট্রিসিটি দিতে পারি, এনার্জি দিতে পারি, তাহলে তাদের জীবন তারা বদলে দিতে পারবে। আমার সৌভাগ্য হয়েছিল উনি যাননি, ওনার জায়গায় আমি গিয়েছিলাম ইউএনওর একটা সেমিনারে, এবং যেখানে বাঙালি হিসাবে ধরেন আমাদের কিছু চিন্তা তো একটু অন্যরকম করতেই পারি আমরা। আমি ওখানে বলেছিলাম আইনস্টাইনের যে গ্রেট থিওরি, অর্থাৎ E = mc², এনার্জি ইকুয়ালস টু মাস ইন্টু লাইট স্পিডের স্কোয়ার। তো সেটাকে আমি বললাম যে আমরা বাংলাদেশে এটাকে ভিন্নভাবে দেখি, অর্থাৎ এনার্জি ইকুয়ালস টু ম্যানস মাল্টিপল ক্রিয়েটিভিটি। সুতরাং মানুষ এই ইলেকট্রিসিটি যদি আমরা দিতে পারি, তাহলে মানুষ তার জীবন নিজে থেকে বদলে দেবে। তার বড় প্রমাণ আপনারা আজকে বাংলাদেশকে যেখানে দেখছেন। এবং এই এনার্জির সাথে সাথে এই বাংলাদেশকে একটা স্মার্ট দেশ হিসাবে তৈরি করার জন্য আমরা আর একটা সেক্টর নিয়ে কাজ করেছি, সেটা হলো আইটি। এবং আমার সৌভাগ্য হয়েছিল শুরুটা 3.5 বছর আমার হাতে ছিল, এবং পলকও আমার সংসদীয় কমিটির মেম্বার ছিলেন। সুতরাং তারও একটা ট্র্যাক রেকর্ড আছে। এবং আজকে সে যেখানে যেই ধরনের কাজ আপনাদের সাথে করছে, আমি বলবো যে যোগ্যতা বলেই কিন্তু সে আজকে এখানে এসেছে। তো আমার শুরুটা আমি একটুখানি আপনাদেরকে বলে যাই এই কারণে যে মানুষকে ধরেই কিন্তু, বাংলাদেশের মানুষকে ধরেই আমরা আগিয়েছিলাম। এবং আমাদের সৌভাগ্য, বিশেষ করে ইয়াঙ্গার জেনারেশন, তারা কিন্তু এটা তাদের নিজেদের বলে ধরে নেওয়ার ফলেই আজকে বাংলাদেশ কিন্তু এত তাড়াতাড়ি আগাচ্ছে। এবং তার বড় প্রমাণ আপনার একজন ইয়াং মন্ত্রীকেই কিন্তু এখানে দেওয়া হয়েছে। এখন আপনারা বলতে পারেন যে এটা হঠাৎ তোমাদের কেন মনে হলো। আপনাদের মনে আছে এভারেস্ট জয় করেছিল আমাদের 2 ছেলে 2 মেয়ে, আপনারা মনে আছে আপনাদের, এবং বাংলাদেশের পতাকা লাগিয়ে এসেছিল। সেটা হয়েছে কিন্তু আমাদের স্বাধীনতার 42 বছর পর। আমি জানি না, এটার আমি কোনো এক্সপ্লেনেশন ওইভাবে দিতে পারবো না, কিন্তু আমি পার্সোনালি ফিল করি যে ওটাই বাংলাদেশের সিমটম ছিল ইয়াঙ্গার জেনারেশন। এই ইয়াঙ্গার জেনারেশন বাংলাদেশকে একটা ভিন্ন পর্যায়ে নিয়ে যাবে। তাদেরকে ডেকে বঙ্গবন্ধু কন্যা জননেত্রী শেখ হাসিনা গণভবনে সম্বর্ধনা দিয়েছিলেন। সেখানে আমিও ছিলাম, এবং আমার সৌভাগ্য হয়েছিল আমার নিজের লেখা কবিতা পড়ার জন্য। তো আমি সেদিন বলেছিলাম, নবপ্রজন্মের এভারেস্ট জয় প্রমাণ খুঁজিয়া পাই, নবপ্রজন্মের এভারেস্ট জয় প্রমাণ খুঁজিয়া পাই, চেষ্টা করিলে বাঙালির কাছে অসাধ্য কিছুই নাই, বাঙালি সব পারে। আবার ওখানে দেখেন সিমটমটা কি অদ্ভুত, 2 ছেলে 2 মেয়ে, 50-50। তো সেটাকে আমি বলেছিলাম নবপ্রজন্মের এভারেস্ট জয় অর্জনখানা বেশ, নবপ্রজন্মের এভারেস্ট জয় অর্জনখানা বেশ, নারী পুরুষের নেই ভেদাভেদ, দিস ইজ বাংলাদেশ। আজকে ওই রকম একটা জায়গায় যেয়ে আমরা দাঁড়িয়েছি, অর্থাৎ সর্বত্র এই 30 লক্ষ শহীদের যে চাওয়া, আমরা মুক্তিযুদ্ধ যারা করেছি আমাদের যেটা চাওয়া, বাংলাদেশকে সারা পৃথিবীতে একটা জায়গায় আমরা নিয়ে যাব, সেই পথে কিন্তু বাংলাদেশ আজকে আগাচ্ছে। এবং সেখানে আমাদের সৌভাগ্য, আমরা বঙ্গবন্ধুকে হারিয়েছি কিন্তু বঙ্গবন্ধু কন্যাকে পেয়েছি। এবং এই যে ডিজিটাল বাংলাদেশ, এই কনসেপ্টও কিন্তু তারই। এবং সেই কারণে আমরা যেটা দেখেছি, আমি এখন বলি পরিষ্কার, ডিজিটাল বাংলাদেশ আর নয় কো কল্পনা। প্রথম মানুষ কিন্তু সন্দেহ করত, ডিজিটাল বাংলাদেশ আর নয় কো কল্পনা। শেখ হাসিনার ভিশন 21 নিছক কোনো গল্প না, এটা কিন্তু প্র্যাকটিক্যালি হয়ে গেছে। এবং আপনারা এতক্ষণ স্মার্ট গ্রিড, স্মার্ট আপনার ইলেকট্রিসিটি, নানা ধরনের কথা শুনেছেন। আমি বলবো সবচেয়ে বেশি স্মার্ট মানুষটাই কিন্তু আমাদেরকে আজকে পরিচালিত করছে। তার একটা নমুনা আমি জানাই। পশ্চিম বাংলার মুখ্যমন্ত্রী মমতা ব্যানার্জি এসেছিলেন ওনার সাথে দেখা করার জন্য, এবং গণভবনে ওনার সাথে দেখা করার জন্য গেছিল। সেখানে যে প্রথমেই বলেছে, দিদি আজকাল তো ইলিশ টিলিশ পাই না। তো উনি সাথে সাথে উত্তর দিলেন, পানি দাও ইলিশ যাবে। তা আমি এটা কবিতা করেই বলি, পানি এলে ইলিশ যাবে কথা অতি খাঁটি, পানি না আসলে যাবে কি করে? পানি এলে ইলিশ যাবে কথা অতি খাঁটি, এমন কথা বলতে পারে কেবল শেখের বেটি। তো একজন স্মার্ট নেতাও আমরা পেয়েছি বলেই আজকে বাংলাদেশ আগাবে। শুরুটা যখন এটা শুরু হয়, তখন কিন্তু নানাভাবে আমাদের মানুষকে বোঝাতে হয়েছে কিছু কিছু জায়গায়। আজকে আপনারা স্মার্টফোনের কথা বলছেন, স্মার্টফোন কি কাজটা করে আমি যদি কবিতা করে বলি, মোবাইলে তথ্য সেবা পাঠানো যায় মানি, মোবাইলে তথ্য সেবা পাঠানো যায় মানি, বাঁচলো সময়, বাঁচলো খরচ, বাঁচলো পেরেশানি, আপনি কেন নেবেন না? এইভাবেই কিন্তু আমরা ব্রোকারি করেছি, অর্থাৎ মানুষের কাছে নিয়ে গেছি। আমার মনে পড়ে প্রথম শুরুতেই আপনার গ্রামে, এখন দেখেছেন আমরা কিন্তু ইউনিয়ন ডিজিটাল সেন্টার করেছি, ফলে আমাদের এখানে কিন্তু ডিজিটাল ডিভাইডটা হয় নাই, একসাথে সারা দেশ কিন্তু জেগে উঠেছে। প্রথম ডিনেটের একটা কম্পিউটার সেন্টার দেখতে গিয়েছিলাম আপনার কাপাসিয়ায়। গ্রামের মধ্যে ওরা একটা কম্পিউটার সেন্টার করেছে, যেখান থেকে তারা গ্রামের কৃষকদেরকে সাহায্য করে, অর্থাৎ তারা কোন ধরনের সার ব্যবহার করবে, কোন মার্কেটে তাদের ফসলের দাম কি। তো আমি যেয়ে দেখলাম যে প্রচুর পরিমাণে মানুষ চারপাশে ঘোরাঘুরি করছে এবং তারা কৃষক বেসিক্যালি। তো এটা যখন আমি এসে বললাম মাননীয় প্রধানমন্ত্রীকে, স্যার আপনার এই ডিজিটাল বাংলাদেশ হবে, বললে কি করে বুঝলেন? আমি বললাম সাধারণ একজন কৃষকও যদি বুঝতে পারে যে এই টেকনোলজি তার কাজে লাগে, তো সারা বাংলাদেশ একসাথে দাঁড়াবে। কৃষিমন্ত্রী মনে করলেন যে এই সুযোগে আমরাও কিছু এরকম সেন্টার তো তৈরি করতে পারি কৃষকদেরকে সাহায্য করার জন্য। ওনারা আরেকটু বুদ্ধিমান, একটা কৃষকের ছেলে যে লেখাপড়া কিছু শিখেছে এবং একটা মেয়ে, দুজনকে নিয়ে এসে এরকম 10 জনকে তারা ট্রেনিং দিল আপনার কম্পিউটারের উপরে, ল্যাপটপে। এবং যেদিন এটা ওপেনিং হয় সেদিন এক ছেলে আসলো, যে কৃষকের ছেলে, কিন্তু লেখাপড়া কিছু শিখেছে। তাকে বক্তৃতা দিতে দেওয়া হলো, সে সোজা দাঁড়িয়ে বলল, দেখেন আমার হাতের মাঝখানটা শক্ত, কারণ আমি লাঙল চালাই। আবার আঙুল দেখিয়ে বলছে যে আমি ল্যাপটপ চালাইতে শিখছি। তো সেদিন আমার যখন বক্তৃতা দেওয়ার সময় আসলো, আমি সেদিন বলেছিলাম, লাঙল চালানো হাতে ল্যাপটপ মানিয়ে গেছে বেশ, লাঙল চালানো হাতে ল্যাপটপ মানিয়ে গেছে বেশ, দিন বদলের যাত্রা শুভ, বদলে যাবে দেশ, এ দেশ বদলে গেছে। আসলে আইটিটা ইজ নাথিং, যে এক্সপার্টরা যারা অঙ্ক করার করবে, কিন্তু মূলত আপনার ক্রিয়েটিভিটি যদি আপনার থাকে, আপনার গল্প লিখি আমরা, কবিতা লিখি আমরা, গান গাই, এই বাংলার মাটি তো এটাই করে। সেই জন্য বাংলাদেশই হলো মুখ্য জায়গা যেখান থেকে আইটি দাঁড়াবে, এবং তার বড় প্রমাণ এরই মধ্যে আপনারা সারা দুনিয়া জেনে গেছে। আমাকে আপনার এক বিদেশি বলছে, তোমরা একটা গরিব দেশ, কিন্তু এত তাড়াতাড়ি আগালে কী করে? তা আমি বললাম, মোবাইল ধরে, কারণ বেশি লোকের হাতে মোবাইল আছে এবং সেটাকে আমরা ব্যবহার করেছি। তো সে বলল, আমি বললাম, তোমরা কি মনে করো বাংলাদেশ? বলে, একটা ছোট্ট দেশ, মানুষ অনেক বেশি, ইটস এ কার্স। আমি বললাম, না, এটাই আমাদের জন্য পোটেনশিয়াল। আমাকে বলছে, হাউ? আমি বললাম, আমার একটা মোবাইল টাওয়ার যে পরিমাণ লোককে সার্ভিস দেয়, তোমার 10টা লাগে, কারণ তোমার দেশ অনেক বড়, তোমরা স্ক্যাটার্ড। তো তখন বলে, না, বাঙালির বোধহয় মাথায় কিছু বুদ্ধি আছে। আসলে ওখান দিয়েই বেরিয়েছে বাঙালি। সুতরাং জাতির জনকের, বঙ্গবন্ধুর মুক্তিযুদ্ধ করার জন্য মানুষকে একসাথে করা, উনি এই মাটিকে বুঝেছিলেন, আর ওনার কন্যাও ঠিক পরিষ্কার সেইভাবেই বুঝেছে। তা এখন সময় এসেছে, আমি এটাই বলবো, দ্য টাইম হ্যাজ কাম, আমরা যাতে প্রতিদিন বাংলাদেশকে আগিয়ে নিয়ে যাওয়ার একটা সুযোগ তৈরি করি। আমাদের আর একটা গোল ছিল, সেটা হলো প্রত্যেকটা লোককে নিয়ে দেশটাকে আগানো। তা আমি কবিতা করেই বলি, প্রযুক্তি প্রগতির পথ বলে গণ্য, প্রযুক্তি প্রগতির পথ বলে গণ্য, ডিজিটাল বাংলাদেশ হতে হবে সব মানুষের জন্য, একসাথে সবাই মিলে আমরা দাঁড়াবো। সেইভাবেই কিন্তু আগিয়েছি। আপনারা এতক্ষণ ধৈর্য ধরে আমাদের এক্সপার্টদের কথা শুনেছেন। সময়ও অনেক গেছে, আমি আর বেশি সময় নেব না, এবং আমার শেষ করার আগে আমাদের যিনি বাংলাদেশ দিয়ে গেছেন, এবং আজকে ডিসেম্বর মাস, অর্থাৎ আমাদের বিজয়ের মাস, আমি আমার নিজের লেখা একখানা কবিতা দিয়েই জাতির জনককে স্মরণ করে আমার বক্তব্য শেষ করব। জন্মেছ তাই দেশের জন্ম, গৌরব অমলিন, অবনত মাথা চরণে তোমার জাতির অনেক ঋণ। তোমারই কারণে জজ জেনারেল হয়েছি মন্ত্রী নেতা, তোমারই কারণে জজ জেনারেল হয়েছি মন্ত্রী নেতা। ভুলে যদি যাই পাপের অঙ্কে পূর্ণ হইবে পাতা, যতদিন রবে বাংলার মাটি পাখিরা গাহিবে গান। সর্বকালের সর্বশ্রেষ্ঠ বাঙালি, জাতির পিতা বঙ্গবন্ধু শেখ মুজিবুর রহমান। আপনারা সবাই ভালো থাকেন। জয় বাংলা, জয় বঙ্গবন্ধু, বাংলাদেশ চিরজীবী।
Thank you, sir. Thanks for reminding us our reasons to be here today. And as you can see, Honorable State Minister for ICT has successfully shown that without the lights, everything can work here, and which our Honorable Prime Minister yesterday reminded us as well, that we should be more efficient as well as very much careful about uses. So I have to be a bit dictatorial now because we are running short of time. We have another seminar at 4, and after that we have this Alok Utsav. I don't want anybody to miss. So I have 4 written questions. These are quite related to each other. I'm going to read first and then ask the presenter as well as the distinguished panelists to respond. Question 1 was, smart grid offers better control to the utility providers in terms of distribution, monitoring, and coordination. Does it also offer the same benefits to the end consumers? Second question was, if we have a smart grid, will it mean that I will be able to share the solar power generated by the panel on my rooftop with a neighbor or a friend? And third question is, what is the magnitude of a smart grid? Is it possible to build a smart grid for an entire country, or does it have to be implemented at the community level? And the last question is, how realistic is having a smart grid in Bangladesh? How expensive is this? If the government decides to install smart grids now, how long will it be before the first of them becomes operational? So I now request honorable ministers or panelists and speaker to respond, whichever you feel like.
What was the last question that you asked? So the question was, how realistic is having a smart grid in Bangladesh? How expensive is this? And if the government installs, how long will it be before the first becomes operational? Yes. Yeah. It is extremely realistic to apply smart grid, but in terms of cost, that's why I mentioned in my presentation, it really needs that cost-benefit analysis to figure out if it's got good value and the return on investment is strong. So a lot of your econometric analysis has to be done upfront. And not only that, you can always do it section by section to meet goals. I would not recommend rushing into a smart grid, as in doing it right now. But once you've done your analysis, once you know what your goals are, it would be very, very easy to implement actually quite quickly. It's not a matter of implementing, but layering on top of existing technology and building the capabilities to be able to manage that and handle that. So that's my short answer.
I just want to respond to one of your question, that is it for the small grid or nano grid or for the whole country? So in my views, so far my understanding is, it is possible to introduce for the whole country as well as for the regional grid, and if you want to connect with other countries, so that is also possible. So we should go for smart grid, because we are, as a middle income country, this is our great opportunity, because we are building the new grid system. So the countries who are already developed, they don't have the opportunity to start with the smart grid, but we have that opportunity, because still we have to build some new local grid, and we are going to be connected with our regional grid. So for that reason, if we can take this smart initiative from our initial start, so it will actually reduce the extra cost. So for that reason, I have another proposal. I just want to make an offer to the Ministry of Power and Energy, because you are connecting some of our islands with electricity connectivity, you are going submerged, and you are also connecting the whole country with your connectivity. So I just want to request to you, please add information connectivity, because if you just take, because PGCB, you have that experience already, you are NTTN license holder, so if you could add our information connectivity in all of your grid connectivity, so it will actually help you to introduce smart grid connectivity easily. So my request to Power and Energy Ministry to add information connectivity in all of your plan and future projects. Thank you very much.
I just want to address one issue regarding renewable energy, because there is a question that if the solar power is introduced, I know that the government of Bangladesh is having plan that they will be having 2,000 megawatt of solar power in Bangladesh by 2021. And for that also they are going for feed-in tariff, that means FIT proposal, so that will attract the foreign investors to come here for the solar energy. So in solar energy, and also there are some experimentation regarding wind energy. So solar, wind, conventional, coal, and all this type of energy, if you want to really optimize the utilization of this energy, you must have a smart grid which is connected and which will be talking to each other. And that is how you can actually reduce the wastage. Like all the lights are on or off already, but we are not feeling that there was any light a few minutes ago, and that was at least consuming few hundreds of watts of energy. So considering that, actually, when we are into different modes of power generation, that means especially when the solar is concerned, you know, in different countries, the only deficiency we have is solar is requiring lot of land. That means for 1 megawatt, it requires 3 acres of land. So that is why actually most of the solar plants now planning in the North Bengal area, that means Kurigram, Gaibandha, and other places. So there, but still 2,000 megawatt of solar, if it comes in the national grid, and if it is distributed through smart grid, that will be really producing lot of energy for us.
In fact, there was a very smart question, and I wanted to answer that question. And the question was whether a solar home system owner would be able to share energy with its neighbor or friend. Yes, you can, if you have a smart grid. And just a scale of that, Bangladesh is the largest in terms of solar home systems. And each solar home system has a built-in capacity of 30% in excess of the actual demand. Yeah? So if you think that 30% of the excess capacity which is there with the world's largest solar home system in the world, what you can do. Yeah.
All right. Thank you so much. I am so sorry. I have also another question, but the speaker is here, and I think you can take the opportunity asking him the same question after this session is over. But I am sorry, sir. May I conclude? Because it looks like we are running short of time, sir. But I think one thing that our presenter has so beautifully concluded in his recommendation is that solution around people's need and not the technology. So I think that is a beautiful conclusion, that we have to find out the solution around the people that we need now. So I thank the presenter for his excellent presentation, distinguished panelist, Honorable State Minister for ICT, and Honorable Minister for Science and Technology for their presence. And especially I thank the audience for attending this seminar without even having any drowsiness. Thank you so much. And I again apologize. I see that there are many enthusiastic face, lots of questions, but we have another session, and then we have Alok Utsav at 6. So we don't want anybody to miss this. And again, thank you all. And especially I thank the honorable ministers to be here. And we hope that as we have seen from the speeches of our honorable ministers, that we are at a juncture of the history of Bangladesh, that we are growing and we are determined, and we hope for the brighter future in near days. Thank you so much.
হ্যালো, কথা শোনা যাচ্ছে? জি, আমাদের পরবর্তী সেমিনার এখনই শুরু হচ্ছে। দয়া করে সবাইকে সিটে বসার জন্য অনুরোধ জানানো হলো। পরবর্তী সেমিনার খুবই সংক্ষিপ্ত হবে, সো সবাইকে বসার জন্য অনুরোধ জানানো হলো। আমরা কিছুক্ষণের মধ্যে পরবর্তী সেমিনার শুরু করছি। সবাইকে আবারও অনুরোধ করছি যার যার আসন গ্রহণ করার জন্য। কিছুক্ষণের মধ্যেই আমাদের পরবর্তী সেমিনার শুরু হচ্ছে। সেমিনার শেষে টি ব্রেকের ব্যবস্থা করা হয়েছে। সবাইকে আবার অনুরোধ জানাচ্ছি নিজ নিজ আসন গ্রহণ করার জন্য। ধন্যবাদ।
I'd like to welcome on stage the moderator for the third and final session,